Once again, welcome to class everyone. This is Networking's IT solution, and this is going to be another topic in our networking fundamentals for tech, understanding what networking really is. And from our scheme, we are going to be considering network components today. We're going to be considering network components, and we're going to have to finish this today. We're going to talk about network devices, which include switches, routers, hubs. We're going to talk about the end devices, PCs, which we are very familiar with, servers, mobile devices, transmission media, cable, fiber optics, and wireless. So like I said, this class is not going to be a class that we are not used to or we are not familiar with. The end goal of this class is actually that we should design our resume, but I want to encapsulate this topic so that once we are done with this topic, we can include it in our knowledge base in terms of our resume that we're going to be preparing for job. So, overview of network components. We're going to understand network devices, endpoints, and transmission medium. So what do we mean when we talk about transmission mediums? That is the device, the technology through which information can travel from one endpoint to another, either within a local area network or a wide area network. So what do we want to look at? Introduction, the objective to provide a comprehensive overview of key network components. Just three things we want to discuss: network devices, end devices, and transmission medium. Network devices. Definition: devices that facilitate communication between different parts of a network. Devices that facilitate communication between different parts of a network. In the last class, we did something on packet tracer, and we did something on VLANs. So we talk about VLANs. So when you are discussing network devices, you are not talking about network devices from the perspective of definition. You are talking about network devices from the perspective of understanding and practical implementation. You're talking about network devices from the perspective of understanding and practical implementation. So, I'm powering up my packet tracer now so that you may understand what we're talking about. So in the last class, if you remember this, somebody did something amazing. The person has even implemented this design and sent it to me. And I'm going to go through. I'm sorry I've not been able to attend to your assignment, or I really didn't give it as an assignment, but the person has gone the extra mile to do the implementation and send it to me. I'm still going to go through it. I've had a very busy schedule, so that is why, but I'm going to do that between today and tomorrow. So we have this design. We said, what are network devices? If we go back to our definition, we said these are devices that facilitate communication between different parts of a network. So this is the sys department or system, is one part of the network. This is the edge. Your router is always called the edge of the network. Now, if there is going to be communication between this PC and the router, you need a network device. That network device is a switch, is a router. So that is what we are saying, that a network device is what facilitates the communication between different parts of a network. And the first device we're talking about is a switch. Everybody hears the word switch. So I want to bring up a hopefully I can get that. So you see switch. Let me just say Cisco switch. Cisco switch. And we go to images. We can see something nice there. So how does a switch look like? A switch is going to have multiple ports. So this is an example of a switch. So we have two different kinds of switch. We have what we call the managed switch and the unmanaged switch. Unmanaged switch is a switch that you cannot configure anything. You don't need to configure. It's a plug and play. We call it plug and play. You just connect your devices. But managed switch is the switch you can log in and configure VLANs, configure trunk, configure access link, configure trunk links, configure VTP, do pruning, and so on and so forth. You can configure security, port security, and so on. So a switch connects devices within a local area network. A switch connects devices within a local area network. Understand this. It is within a local area network. That is what a switch does. A switch connects. And another thing you must understand, this question comes up in interview. What layer of the OSI model does a switch operate? It operates in layer 2. We have 7 layers of the OSI model. That will be our next class. The 7 layers, we explain them. We do some practical implementation of them on Packet Tracer. We have 7 layers. The data link, we have the physical layer, we have the data. So the switch operates at layer 2, and it uses MAC address to forward data to the correct device. Can be a managed or unmanaged switch. So let me explain what we're saying here. So on our packet tracer here, if we come to this device on the first PC 0, it does not have an IP yet, and as a matter of fact, it picks an APIPA IP. So let's see if it's going to pick APIPA again. If it picks APIPA, we need to go and check our DHCP server and be sure that it's operational. Hopefully we save our configuration the last time. Somebody sent me a message today and was explaining the fact that he knows how to. So let's say show run, and let's see if our DHCP server is there. Okay, the DHCP server is working, and we have the network 20 network range. Okay, so fine. So let's try it one more time and see if it's going to get IP from the DHCP server. Still didn't get IP. Let's go to another PC and see. Just give me a moment. So this is PC2, and let's see if it speaks an IP address. So this picks an IP address of 192.168.20.26. Okay, so that's PC2. Let's check PC1. Let's check PC1. Sometimes we could have a bug. So let's see PC1. Okay, PC1 is not also getting an IP address, but there's something we can know. To troubleshoot this, we can come to our switch here and try to know. So show IP interface brief. So we know that fast Ethernet, we can do show interface description. Show interface interfaces. So we are looking at all the interfaces. So for us to know which interface is connected to the router is connected to fast Ethernet 0/1. So we need to know what VLAN, show VLAN. What VLAN is fast Ethernet 1 connected to? Is connected to the default VLAN, VLAN 1. But PC 0 and 2, they are on port 11 and 12. So if we look at PC 0 is on port 11, if you can see it here. PC 1 is on port 12. Is on port 12. So because they are on a different VLAN, that is why they are not getting IP address from the DHCP server. So if we do show MAC address table now, if we do show MAC address table, we will see we are learning from fast Ethernet 0/1. This MAC address now is the interface, is the MAC address. Now for 11, this is the MAC address of the PC 0. Why this is MAC address of PC 1, and you can see the VLAN. This is the MAC address of PC 2. Okay, so and we are getting 16, port 16 and 17. So PC 0 and 1 are having this. Now fast Ethernet 13, let's check. If you look at it very well now, you will see that 13, this is port 13. Port 13 is on VLAN. If you see it here now, port 13 is on VLAN 1. That is why PC2 can get IP address, while PC1 and PC0 could not get IP address because they are on a different VLAN. So if I want PC1, PC0 now, for instance, to get an IP address, I can put it on VLAN. So PC0 is on port 11, which is VLAN 10. So I can switch it back and say interface fast Ethernet 0/11, switch port mode, access, switch port, access VLAN 1. Once I do that and I do show VLAN, you will see that port 11 now has gone back to the default VLAN. In other words, I can now, this PC should be able to get an IP address now. If I go back and do DHCP, it's going to get 192.168.200 or 20 dot. So now, because that port we still have to go through listening, and you see now it's already getting the IP 192.168.20.27. Now if I try to do ping from this PC to the other PC, that's PC2, because that is in the one that 192.168.20.26. You see, now we need to see what is the switch using to. So if you do show MAC address table, now it is this MAC address that the switch uses to pass or transmit information at the layer 2. So what MAC address is to a switch is what IP address is to a router. So the switches uses MAC address to transmit data in layer 2. So MAC address to forward data to the correct device. How do I know? Or what happens? So when a switch receives a packet, at first, if it is the first time, it's going to broadcast that packet to all the ports in that VLAN. Broadcast it. But once it does that, when they respond, he will know the MAC address of everybody connected. And from that point on, he will store the MAC address on what we call the camp table. The camp table, that's the memory table of the switch. So from there, so when next the person is sending any other packet or data, he already has that MAC address of that device, and he can forward it to just only that particular device. So that is what our switch does. Number 2 is a router. If you have a question, you can please just type it. I'll pick it up. I'm going to see it, or you can raise your hand and we'll pick it up from there. What's a router? A router connects different networks, such as LANs to WANs, and even from WAN to WAN. So a router, let me show us a picture. I'm sorry, I had to quickly do so. So the Cisco router. So this is how our router looks like. A router has a limited port. It's not like a switch. It always have a very few ports compared to switch, because you just need to have the WAN leg and the LAN leg. So this is what a router looks like. And these are physical devices, very expensive. You can, and that is why it has to be, you don't, it's not what they just give to anybody to configure. You must be a professional to be able to configure it. Okay, maybe a router that is worth 2 million, 1 million, 5 million, because you don't know how it is being configured, you go and just press any command, and before you know it, the router is gone. So this is how, or what a Cisco router looks like. However, we have small routers as well. Like we have macrotic router board, which is what I'm going to teach us soon how to configure. So this is a macrotic router. This router is encompassing of both switching and routing. Okay, so this is macrotic router. This router board, this is very, very solid router. Most ISPs use it as their deploy it at their customer end. So very good router. So this is this. What are the key features of a router? It operates at layer 3. Please pay attention to this. A switch operates at layer 2. A router operates at layer 3 of the OSI model. It uses IP address to route data between networks. We said a switch uses what? MAC address, while a router uses IP address to route traffic between network. It can perform network address translation. I've explained this to us before, and I said that is the reason why we are still even using our IPv4 address up to today, because the router has the capacity to do NAT address translation or network address translation, and it provides firewall protection. Yes, it does, but at a minimal level. It's not like our firewall devices. What a router can do is we can configure access control list, ACL. We call it ACL. We can configure access control list to permit a particular range of IP, for instance, to have access to your network and deny some. Okay, so those are the things it can do. Then we have a hub. This is ancient, a basic device that connects multiple Ethernet devices together. You will rarely see a hub in any network today. The reason is, unlike a switch, a hub will always keep broadcasting to all ports. Okay, I want to see if there's even a hub. Okay, so there is a hub here. This is a hub. So a hub, every time you are sending data from the PC, if you connect 20 PC to this hub, if you send data from one PC to another PC, just between two PC, is going to be broadcasting it to all the 20 PC every time, and that will always cause traffic jam, and there's going to be slow network. Then it's going to consume a lot of bandwidth. So most time this is no longer advisable on any infrastructure. Okay, we said the key features. It operates at layer 1. You can see it operates at the layer 1, which is physical layer of the OSI model. Broadcast data to all devices connected to it has been largely replaced by switches due to inefficiency and collision. So note that they can ask you what is the difference between a switch and a hub. A hub operates at layer 1. A switch operates at layer 2. A switch is intelligent. Once it learns your MAC address, it keeps record of the MAC address in its CAN table, and it's able to forward packet between the end devices from there on. End devices, we already know what end devices are. Devices used by end user to interact with the network. One of these devices is our PCs, personal computers. The function of the PC is the most common type of end device for accessing network resources. Use case is internet browsing, email, document creation, gaming, etc. So that is the first thing. Then we know about servers. I've taught us about servers before. For those of us that have been in class, servers, what are the functions? A server provides resources, data, and services to other devices on the network. What are the types of server that we have? We have web servers. When we open a website and we are seeing maybe your Amazon or whatever place we are shopping online, there is a web server behind that is displaying those pictures or images that we are seeing. We talk about file servers, database servers, application servers, etc. Then lastly, we have the mobile devices. What are the functions? Portable mobile devices. Most of us are connecting with our mobile devices to the class now. They are connected to the network wirelessly, and examples include our smartphones, our tablets, our laptops. Use case is still for internet access, communication, and application. So what is the summary of today? We've looked at what network devices are. which is switches, router, and hub. Endpoint devices, we see PC, we see server, we see mobile devices, transmission media. Okay, so transmission media, we have our cables. So let me show us our Cat6 cable, for instance. So Cat6 cable. So some of us would have seen things like this. So this Cat6 cable. So we need to know about the color coding. That will be our assignment. So please write it down now. What is the color coding? So we have different ways of crimping cable. We have what we call the straight cable and we have the crossover. So yes, you see something of carton like this. It's always in a carton. Then these are the color code. Oh, how do I, so that it can pass or carry traffic. So we have straight through and we have crossover. So for instance, on our, you will see it here in our packet tracer. You will see if you put your console on the cable, this is console cable, and the second one you see copper straight through, and then you have copper crossover. Copper straight through, copper crossover. So even though at the emergence of technology, initially there is a need to ensure that you are using the straight through is between end devices to a switch. But when you want to connect switch to switch or router to router, you can now begin to look at, I need to use crossover. But then technology has advanced beyond that. So sometimes you can just automatically pick whatever cable you feel like and it will still work for you. But then it's good that we understand this part. Then I want to show us fiber optics cable. Fiber optics cable. Some of us we are opportune to have worked in a fiber company, and you already see how fiber optics, it's actually a glass. Yes, this is how fiber optics looks like. So we have what we call 96 core, we have 42 or 48 or 48 core. So different cores, and it's used for high speed. It can carry large uh, amount of, so these are the connectors that you use. Just like our Cat6 cable, we have what we call RJ45 for the connectors. So these are the pins for the connector for a fiber optics cable. So very reliable and very good. So it's a thing that we could consider. I think earlier today, I still have a job offer that came for a fiber engineer. So wireless, that's what almost all of us are doing. So we're going to have to do once we are going to do a practical, we'll buy a Microtik wireless device and we'll configure it to broadcast Wi-Fi for us, and we'll be able to use it in our home. So what is the importance? We need to understand these components. Understanding these components rather is crucial for building, managing, and troubleshooting networks. So thank you so much. Is there anyone that has any question? I want to stop this class so that we can now work on building our CV. I don't want to put that in the recording. Any question, please? Do we have any question? Okay. If there's no question, okay. None from my end. Okay. I've gotten a chat. One person said none from my end. Okay. Any other person? Okay. So this class is just about